I think I'll call it the Silly Sailor. I think he's supposed to be a sailor. I just got to build it. I hadn't built an animatronic model for quite a few years now. But when I saw these two, I thought, yeah, they're made for each other. It's a traditional sort of thing. It's not what I've really built before. I've really stuck to doors that open, a bit like cuckoo clocks, and things that jump up, a bit like jack-in-the-boxes. So this is a departure for me. It amuses me though, so I press the button. And the man puts his head into the teeth, which then open and close. So how does it work? Well, essentially it's based on a cam, a snail cam. So the snail cam at the back is made out of a piece of plastic. It was originally made a wheel, cut out a wheel, then cut in the slot and then gradually deepen the slot until I got the right amount of movement to open the teeth. I then gradually got it to go back to the top so that the teeth are raised gradually, and then they stay open all the way around until it reaches the slot again. So will it work? Let's try it. So we can see that this cam follower down at the bottom is a long rod with a nut at this end. I put a thread on it and a nut on there, and two lock nuts with a gap between them so that it isn't fastened into this piece of aluminium. So it doesn't move from side to side. I put it in another piece of aluminium, put a slot in it and put the rod in. So that's how my rod or cam follower goes up and down. To get the rest of the mechanism, I've put a pivot onto the cam, which essentially is just a bolt that goes into the cam and has a tab washer on it. Onto the tab washer I've soldered a paper clip straightened out, which goes to the other end where it comes to a crank at this end. I've actually gone posh on this and used a bit of brass rod rather than a paper clip for some reason, which I've forgotten in the distance of time. But this crank here then connects through and connects through to a crank at this end, which connects to my mariner. At this end, instead of having a tight fixture onto the crank, I've left a gap so that when the sailor is down, he stays down for a little bit longer than he would if I put a tight. Fasten that on there tightly. On the back of the sailor then I've got a link, or a connecting rod from the sailor down to this crank. Gone posh and put a couple of bits of brass tubing on it, solder them on at the bottom and at the top. The one at the top needs to go off to the left to come off, and the one at the bottom needs to come off to the right, so therefore that tends to stay on. So that then is how the mariner works up and down. And that basically is the mechanical part. The electronic part, got a button which I press to supply power to this circuit board, which is a 555 timer, which controls a relay. Probably over the top, but it works. So the time is geared by, if we can zoom in a bit, we can see here a variable resistor which affects the time. That's my 555 timer somewhere. There's the 555 timer, there's the relay, there's the timing capacitor, and there's a little LED just to show that it's working. That then is powered by a lithium cell. This came out of a computer battery or something like that, so I've had to solder on a protection board at this end. It perhaps ought to be enclosed somehow, as lithium cells can be very dangerous, so I ought to protect it. The lithium cell looks to be about 635 milliamps, so that means if the motor's 30 milliamps, it should run it for 2 hours, far more than I should need. If I look at the motor, this has got a gearbox on that I built myself. The gears sort of come from a company called Opitech. By golly, it looks like it's got a funny gear there, but it seems to work. What I've done is to put a 3mm, I like my 3mm tubes, on to the end of the motor, soldered it onto the motor shaft, so that then comes out to the red gear here, and you can see the 3mm tube just sticking out the end. The large gear on the end here isn't actually used, but it's the pinion on the inside which drives a gear here. The red gears fit tightly on the shaft, and the white gears should be slack on the shaft, so therefore these can turn without altering the shaft. So this pinion here turns this gear here, so when this goes round 3 times, this goes round once, and when this pinion goes round 3 times, this goes round once. And if I was clever, I could work out what the reduction was, how many 3-to-1s I've got. So it will be, this one would go round 1/3 the speed of that, this one would go round, is it 1/9 the speed of that one, and so on and so on. So we've probably got about 120 gear reduction. The final gear here, which is on the output shaft, I've put a pin through, or at least a bit of wire, drill through the gear which isn't used. This small pinion isn't used, so I've drilled a hole through it, through the brass, and that then locks this gear onto the output shaft. The pinion itself, sorry, the pinion, I have no opinion. I've a cam, what's this thing called? A snail cam again. My snail cam then fastens onto the output shaft using a grub screw, which is just basically a bolt cut down and a slot. Don't know if we can see it. Cut in the end so that the camshaft, the snail cam, is connected onto the pinion, onto the shaft. What am I trying to say? Onto the output shaft, and so it shouldn't slip, although it's a tight fit anyway. So that then is my, I think I'll call him the silly sailor. So when we press the button, we can see the sailor moving away from the teeth. It amuses me, and if it amuses anybody else, then it's all been a worthwhile activity. Yep, enjoyed that. Bye now.